Nature is a symphony of patterns. From the intricate veins of a leaf to the vast spiral of a galaxy, there exists an underlying order that has fascinated scientists and artists for centuries. This order, we've discovered, is often expressed through the language of mathematics. Among the most prevalent mathematical concepts found in nature are the Fibonacci sequence and the golden ratio. These principles are not just abstract equations, but are fundamental to the very structure and efficiency of life itself. The Fibonacci sequence, named after the Italian mathematician Leonardo Fibonacci, is surprisingly simple. Starting with 0 and 1, each subsequent number is the sum of the two preceding ones. 0, 1, 1, 2, 3, 5, 8, 13, and so on. This seemingly basic sequence, however, gives rise to a remarkable phenomenon known as the golden ratio. This ratio, approximately 1.618, is found by dividing any number in the Fibonacci sequence by the one before it. What's astonishing is how these two mathematical principles, the Fibonacci sequence and the golden ratio, manifest throughout the natural world. They dictate the arrangement of seeds in a sunflower, the spiral of a nautilus shell, and even the majestic sweep of a galaxy's arms. These patterns are not mere coincidences, but speak to a deeper efficiency and harmony inherent in the natural world. Let's delve deeper into the Fibonacci sequence. Imagine a sunflower, its face a mosaic of seeds. You might notice that the seeds are not scattered randomly, but arranged in spirals that curve both to the left and right. Count these spirals, and you'll likely find a pair of consecutive Fibonacci numbers like 34 and 55. This isn't unique to sunflowers. You'll find the Fibonacci sequence dictating the arrangement of pinecone scales, the petals of a rose, and the branching patterns of trees. But why the Fibonacci sequence? Why has nature chosen this specific pattern? The answer lies in efficiency. The golden angle, approximately 137.5 degrees, is directly related to the golden ratio. When elements in a system, like seeds in a sunflower, are arranged at the golden angle, it allows for the most efficient packing, maximizing the number of seeds that can fit within the flower head. This principle of efficient packing extends beyond sunflowers. Think of a tree, its branches reaching out towards the sunlight. The Fibonacci sequence dictates the arrangement of these branches, ensuring that each leaf receives optimal exposure to sunlight, crucial for photosynthesis. This efficient use of space and resources is a testament to the power of the Fibonacci sequence in nature. Now let's turn our attention to the golden ratio. Often represented by the Greek letter phi, this ratio is approximately 1.618. It has captivated mathematicians, artists, and architects for millennia, considered a proportion that is inherently aesthetically pleasing. But the golden ratio is more than just aesthetically pleasing. It underpins the structure and growth patterns of countless organisms. Take the nautilus shell, for instance. This marine creature builds its shell in a spiral that expands outward. The ratio between the spiral's successive diameters is remarkably close to the golden ratio. This allows the nautilus to grow without changing its overall shape, an incredibly efficient design for an organism that carries its home on its back. The golden ratio isn't limited to the animal kingdom. The spiral arms of galaxies often exhibit proportions close to the golden ratio. These vast cosmic structures, composed of billions of stars, echo the same mathematical principles that govern the growth of a humble nautilus shell. From the smallest organisms to the grandest structures in the universe, the golden ratio is a testament to the elegant efficiency of nature's design. The prevalence of the Fibonacci sequence and the golden ratio highlights a fundamental principle driving the natural world efficiency. Throughout evolution, organisms and systems that utilize resources efficiently have a greater chance of survival and reproduction. The golden ratio and the Fibonacci sequence offer precisely this advantage. Whether it's packing the most seeds into a sunflower head, ensuring optimal sunlight exposure for leaves on a tree, or enabling a nautilus to grow without altering its shape, these mathematical principles offer a competitive edge. They are a testament to the power of natural selection, favoring traits that promote survival and reproductive success. In conclusion, the Fibonacci sequence and the golden ratio are not merely abstract mathematical concepts, but fundamental principles woven into the fabric of the natural world. They demonstrate the elegant efficiency of nature's design, from the smallest organism to the grandest cosmic structures. So the next time you encounter a sunflower, a seashell, or even gaze up at the night sky, remember the hidden mathematical language that underpins their beauty and efficiency.